we get going, I did want to make a couple of announcements. I wanted them on screencast, ultimately on YouTube, because so many people are not here. Okay, I guess first, my office hours have changed because sometime either yesterday or over the weekend or sometime was midterm, okay? And now we're in the second mini-term. That means today I start a second mini-term course. I had a first mini-term physical science, and I'll have a second mini-term physical science starting today. However, they start at different times. So before today, my Tuesday-Thursday schedule was office hours 10:45 till 12:30, but from now on, the rest of the term, 10:45 to 1:15, because it's automotive students, they don't get through their last module until 1 o'clock. So we start in physical science at 1:15, which means, of course, I go until 5:45 this evening rather than 5 like it used to be. So, but I do have longer office hours on Tuesday, Thursday. So that starts today and will be the rest of the term. Next, we're going to get school stuff taken care of first, I guess. Since we are starting, we have just passed midterm, sometime recently in the last few days have passed midterm. Now for about a week on the academic calendar, they have out there midterm progress reports due, okay? Let me explain to you what that means. They want us, the instructors, to notify the system any students that have D's or F at midterm. Now, I'm preaching to the choir here, I feel like, because most of you are, have stuff turned in. Maybe not everybody, but most of you have. I've had 5 people in this class turn in papers, which is not bad, but it could be better. All right, here they come. All right. Just finding you is the problem here. Tyrell is here. And Amber Jones is here. I have to make sure I stay on the right line across the page. Way to go. Okay. So only 1, 2, 3, 4, 5 people have turned in the paper. 1, 2, 3, 4, 5, 6 people have, 5 people have not turned in the first quiz. Okay? Only 1, 2, 3, 4, 5, 6 people have completed the first test, or at least as far as I can tell have completed. And your grades are on Blackboard. I don't know if you can pull up Blackboard. Have you ever been able to? It is, okay. If you don't see your grade there, that means I don't know whether you finished the test or not. So let me know if you have. I'll put your grade out there. If you haven't, please complete it. So the point is, there's quite a few people for whom I have no score whatsoever, okay? If they do ask for, and here's the other thing, they have it on the academic calendar, but sometimes they forget to open it. Okay, so if they don't open it, I'm not reporting. But if they do open it, I'm required to report. So if they do open it and say we have to have it in by Friday or Monday or something like that, then I have to report anyone who has a D or an F at midterm. I need to report that. So please get me something in this week, if possible. Your paper, your quiz, or finish your test, okay? Just glancing here, I see just a couple of people who have scores, even though they turned things in, they have scores that are still below 70. So you need to get something else, or maybe it's okay to report that because maybe you do need, counseling or tutoring or something like that. And that's what it's all about. It's not to put anyone on report. It doesn't hurt your grade or anything. It just alerts the counseling area that maybe some students need some help. Yes. You can always go see a tutor or a counselor anytime you want to. There's no, you don't have to wait for them to contact you. You can go see them. Yeah. And that's, anytime. Okay. That's those two things. One more thing. This deals with tomorrow evening. I don't know if you know about the movie. Have any of you seen Hidden Figures? You have. Wow. What a story, and a pretty good movie too. But what a story. Okay? We have been invited, Lawson State has been invited to go to, because at UAB Hill Community Student Center and the Alumni Theater, they're showing Hidden Figures tomorrow evening at 5 p.m. Okay? And we can go. We've been invited to go. So, if you want to go. Now, there may be transportation leaving, I'm guessing, from the Birmingham campus. I don't know for sure, but I do know that the Honors College and the STEM program probably are going to be encouraging their students to go, so they may be providing transportation. Normally, I would be driving a van, except I live right near UAB, so I really didn't want to drive back out here and then drive back home again. So hopefully there is some transportation being arranged, but I can't swear that it will be. But anyway, it's tomorrow evening, 5 p.m. Now, do all of you know how to get to UAB? That's the first question. Where UAB is, how to get there? Okay, how about Hill Student Center? Do you know where that is? Any of you who do not that might want to go? Anyone? It's pretty easy to identify, but okay. Oh, we do we? Yeah, is this a tournament starting? It starts today. Okay. Oh, here they come. We've been waiting for you. Okay. Justin's here. Jeremy's here. And Ashley's here. All right, good deal. I was just telling everybody, Lawson has been invited to participate in seeing Hidden Figures. If you haven't seen the movie, I can't remember how many Academy Awards they won. I know they were nominated for several, but I've seen it. It's an incredible story and quite a good movie too. The story is just unbelievable. But UAB Hill University Center, Alumni Theater, tomorrow evening, 5 o'clock. Okay. As far as I know, it's free. Has anyone seen whether there's a cost? I haven't. I've just heard a student wrote this out for me and didn't put anything about cost. And you know about Hidden Figures? You do? Is there a cost to that? No, I didn't think so. And is there any transportation being arranged? If you know that. Okay. You're supposed to know everything. Didn't you know that? Okay, Ryan's here with no information at all. No. All right. So that's tomorrow evening, 5 o'clock. Does anyone need directions for how to get to UAB or to get to the Hill University Center that wants to go? If you do, please see me. Easy to do. The trouble is parking, okay? There's no really good, easy parking around UAB, but hopefully around 5-ish or so they won't be ticketing as much, but I can give you some hints on where I'm going to try to find the park if I wind up being able to go, okay? So, please consider it. It's a great movie. All right, I think I've marked everyone as they come in. Let me pick up to where we left last time. I think we're on example 4. And, any questions before I get started? Anything we've covered so far? Okay. Yeah, they skipped example 4, and that's why I was on this page at the end. It says, write the equation of a parabola. Write the standard form of the equation of the parabola whose vertex, let me get my pen fixed. Okay, we know the vertex is the point. I've lost it. There it is. 1, 2. And it contains another point. It passes through the point 3, -6. Now this is a little reminiscent, isn't it? Back when you did two equations, two unknowns, and you did lines, if they gave you 2 points, you should be able to find the equation of a line, right? There was a point-point equation formed for a line, okay? Well, we don't have anything quite like that, but it's the same kind of concept. You get two pieces of information, you should be able to identify the curve, okay? Boy, whoever did the erasing didn't do much erasing. Okay. Now, someone tell me how to begin. They gave you a hint. Write the standard form of the equation of the parabola, okay, whose vertex is 1, 2, and passes through the point 3, -6. How would you begin? Say again? Okay. Yeah, we can do either y equal, and that may be a good way to go. Y equals what? A times x minus h, squared, plus k. That is the standard form for a quadratic function. Now, we've written it as an equation, which I think is what they really want, and that will serve us well. Except I have no clue what a is. Do you? I really do have a little clue, but I'll tell you that in a minute. How about x and y are variables. You're not going to do anything with them yet. Okay? How about h? What in the world is h? Say again? It is 1 because this is your h, your vertex. That's the x coordinate of your vertex is always hk. So we know we can start this process. Y is equal to a, we still don't know what a is, times x minus 1 squared plus 2, because that's your 2, plus 2. Hey, we're 2/3 of the way there of writing the equation in standard form for that parabola. All we need is to figure out what the a is. Okay? Now, we've used this point, the vertex, as much as we can. We've sucked every bit of information we can out of it. Now, we haven't even touched the point. What could we do with that point? Ah, very well. This is an x and that's a y value. Plug this in, figure out what a is, then put it back into this form. Sounds like a wiener to me. So what do we put here? -6 is equal to a, which we don't know, times 3 minus 1 squared plus 2. Okay? Let's go from there. What would you do first? Say again? 4a, because 3 minus 1 is 2, squared is 4, times a is 4a plus 2. Next. I'd subtract 2 from both sides, and that gives us -8 is equal to 4a, divide by 4, and that gives you a is equal to -2. Now we've got it. Go back and plug it in. Y is equal to -2 times x minus 1 squared plus 2. We plug those in there to find a, but once you have a, your equation needs an x and a y in it. So you go back to this form and just plug in the a there. Does that make sense? That is it. Yes?
Does a equals -2 have anything to do with that x equals -2 up there?
That was example 2. I should have. Okay, no, it doesn't. Not that. Okay. Now, does this make sense? Why? Okay. When I said we don't know anything about A, I said, well, yeah, we do a little bit. Here's what it is. Here's the vertex. The vertex is either going to be the lowest point or the highest point in that parabola, right? Okay, it's at 1, 2. Buckle my shoe. Okay, this is at 3, -6. So what does that tell you? It's going down, and that tells you something about A. It's got to be negative. We knew it had to be negative because of that point. If that point had been above it, if that had been a +6, then it would have had to been going up. Because the y is a -6 below 2, that means it had to be going down. So it had to be a -A. And sure enough, it makes sense. We have a -A. What's the right one? We don't know. But yeah, we know it. We did it right. Okay. Now they actually draw it here. I didn't leave lots of room for drawing, but let's do that. I'm going to let that be my x-axis up there. Okay? Let's tick off a few points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We won't need half of those. -1, 2, 3, 4, 6, 7. We won't need most of those. +1, 2, 3, 4, and -1, 2, 3, 4, 5, 6, 7. Okay. So we know the vertex is 1, 2. That would be up here. All right. We know the point is going to be 3, -6. 1, 2, 3, down 6. 1, 2, 3, 4, 5, 6. Somewhere right along in there. Now, what else can you tell me that will help me draw this? You want me to draw it in a different color so it shows up better? What color? Red? Okay, he's pretty alarmed today, I guess. Okay. Whoa! There's a point, and there's a point. Now, they didn't mention this, but it's something we can draw in because you know what it is. The axis of symmetry. What is the axis of symmetry? Line that goes, the vertical line that goes through the vertex. Vertical vertex, okay. And what line would that be? X = 1. It's always X = H. There you have it. So X = 1 will be this line right here. I really didn't need to do up any because it's only going to be coming down. Now that I've drawn that, you can tell me another point on this curve, can't you? -1, -6. Very good. Why could he say that? Because it's a free country. No, it's because this is 2 units from here. This is going to be 2 units from there. I don't draw very well, but you got the idea. And now we can pick out another point. In fact, a really easy one. Yeah, let x = 0. So let's take this form right here. Put x = 0. What does this give us? -1 squared is? Times -2 is? +2 is? 0. Wow, 0, 0. Who would have thunk it? Okay, goes right there. Can you give me another point? 2, 0. Go across the axis of symmetry and you got it. And frankly, those are the only points we're going to be able to do on this scale. So let's just draw our parabola in there. Something that looks like this. And does that kind of make sense? If I could draw, okay. Well, you've got your vertex right. It's a inverted, the negative, flips it across, inverts it, and then the 2 stretches, a vertical stretch. We got a horizontal shift to 1 to the right, 2 up. We had those, that's why I said the vertex, and then we have a flip and a vertical stretch. Yeah, that's looking pretty good. They show it in the book, maybe not quite as pretty as mine, but close to it. Okay. Make sense? All right. Let's move on to finding minimum and maximum values. Guess what? We've just been doing it, haven't we? Okay? Many applications involve finding maximum and minimum values. Say you're a business owner. Guess what you want to maximize? All right, he wants to pay his people really good. Good man. He wants to maximize their salaries. I'm working with you for you, okay? All right. What else? Income, yeah. Most of us want to do that. Profit, okay. What things might we want to minimize? Cost, very good, okay. Things like that, okay. So quite often we're interested in, if we're given a situation, what do we really want to maximize? Now, much of my training, academic training, was in agricultural issues. And for many years, American farmers were always shooting for maximum yield, okay? Make the most they could. But you know, after a while, they figured out that was costing them more. They wanted to make maximum profit rather than maximum yield. Guess what? You can get more yield if you pour the fertilizers on there, but after a while, the extra cost of the extra fertilizer, you're not going to make it up because you're only going to marginally increase your yield. So maximum yield wasn't the thing to go for. It was maximum profit for a while. But now that we're a little more conscious of our environment and how long we can sustain stuff, they now are urging people to go for maximum sustainable yield or profit. You know, in other words, don't overstress the system, or else it's going to break on you. You're not going to be able to maintain it. So they're looking for maximum sustainable yield and those kinds of things. So you see your maximum, but they're still looking for maximum, okay, or minimum damage to the environment, you know, or things like this. So we're always looking for max and min. So by completing the square of a quadratic function, hey, we've done that, haven't we? That's how we got our standard form, wasn't it? You can rewrite the function, this, to be yuck. That doesn't look anything like what we're doing, or does it? What's the first thing we would do here? Factor out the a. So we did that. That gave you x plus b over a, x squared plus b over a x. See, they're skipping a bunch of steps, so let's do it. Now, it's a lot more fun, I'll admit, to do it with numbers. But we can do it with letters, can't we? Okay? So let's take this. Let me go back to a dark color. Okay? First thing we're going to do is factor out that a. That leaves me x squared plus b over a x blank, remember, they don't usually do that, plus c. Okay? Now, so far, we haven't changed the thing except pulling out the a. If you multiply through, you get ax squared plus a cancel out plus bx plus c. Yeah, haven't done anything wrong. Now, what's the next step? Once we got to here, what do? Take half of this, and that's b of 2a. There it is, okay? And like I always said, write it down underneath there. And then what's the next thing we did? We squared this. Squared the b over 2a. And what was that? b squared over 4a squared. Perfect. Okay? Now, we just added something there, didn't we? We just added this. That's changed the equation, unless we subtract it too. But it wasn't just this. We added a times this. So what is a times this? Okay, b squared over 4a, right? So we're going to subtract it over here. Minus b squared over 4a. Now we have exactly, all we have to do is take this, just like I said to do before, and write it as the square of a binomial. Half of this goes here and then squared. Okay? So yeah, this is how we got it. That's our standard form, where this is my h, the x component of vertex. And this is my, the whole thing here is my k. The whole thing is the k. The thing that follows this is my h, except this is minus h, isn't it? remember it's minus h. This is a plus. So the opposite of this, minus b over 2a, would be my h. Right? Who cares about the k? That's too complicated. We won't mess with that. But the key here, that's my h. And what is h? The x component of your vertex. Exactly. Okay? So here's what we know, that h is equal to minus b over 2a. Okay? Now, so guess what? So the vertex of the graph is, the x component is minus b over 2a. Now you could have said the y component was that c minus b squared, or, boy, that's so complicated. Why don't we just take the x component, plug it into the function, and that's what we'll get. That's usually easier than doing c minus b squared over 2a, 4a, you know. That's so much writing to do. This is usually easier to do. There's your vertex. Okay? So what does that mean? What is the vertex? Either the minimum point or the maximum point. Exactly. So your minimum maximum values for the quadratic function, consider this function, and we can just take minus b over 2a. Minus b over 2a, write it down, that is your x component of the vertex. Plug it in here, and when you have numbers, that makes it really easy, and get what f is, that is your y component, or your h. Okay? Now, if this thing does come up to be positive, well, can that ever be positive? B could be negative, too. Or A could be negative. Now, if they're both negative, no. Or if they're both positive, no. It's going to be negative. But you got a 50-50 chance it's either going to be positive or negative. If A is positive, I'm sorry. If A is positive, okay, F, I'm sorry, not this, the A. If A is positive, this is what we did before. If A is positive, then this is a minimum because it's opening up. And X equal minus B over 2A is the X component there, and the Y component is this one, the K, okay? And when A is negative, when this A is negative, same way as we did before, then you know this is a maximum value. And that's going to be at X equal minus B over 2A, which could be either positive or negative. Either of those could be. Okay? But you know from here, if A is negative, it's opening down. So the maximum value then is the Y value. Okay? The K. You can either get the K from that C minus B squared over 4A, or if you wanted to, but man, it's so much easier to just plug it in here. That will give it to you. So, what does this mean? To get that vertex, you don't have to get it in standard form anymore. It might be fun to do. We love doing it, right? But all you have to do is in this form here with minus b over 2a. That's going to be the x value. Plug that into the function, and you got the y value, the h and the k. Without doing standard form. You've done it once. Remember when we did the quadratic formula once? You didn't have to go back and do that anymore. You had it. Same thing here. In fact, speaking of the quadratic formula, can anyone tell me what it is? If this was your function, you're looking for the equal 0, where that's equal to 0, we'd say x is equal to minus b plus or minus the square root of b squared minus 4 ac over 2a. Guess what, folks? Minus b over 2a is where you start, and then you go plus or minus from there. Or where you start and go plus or minus from there. This is telling you exactly the same thing. Minus b over 2a is your vertex. Okay? So it's nothing new. You've had it before. You just didn't talk about it before because we didn't talk about vertices then. Okay? But now you got it. Minus b over 2a. All right. Let's do example 5. The path of a baseball. Good problem, right? Okay. After being hit is given the function. You do this every time you swing, right? You think of this function, right? Yeah, absolutely. F of x is equal to minus 0.0032 times x squared plus x plus 3. Okay? Where f of x is the height of the ball in feet, and x is the horizontal distance from the home plate in feet. Okay? Now, does this make sense even to begin with? At home plate, how far is the baseball from home plate? How far is it? At home plate, how far is it from home plate? 0, right? And when x is 0, how high is the ball? Is it at the sweet spot? You don't want to dig it up and down around your ankles. You don't want to swing that up here. 3 feet right about waist. That's where you can really pop it out of there, right? That's, you hope the pitcher puts it right there, okay? So that is the initial height. When x is 0, the height of the ball hopefully is 3. In this problem it is anyway. Okay, and then you go from there. So, what is the maximum height of the baseball? What are we looking for? By the way, what kind of path does the baseball follow? A parabola. What kind of path does the basketball follow? Except for dunks, they go straight down. Okay, but any shots are going to be parabola. How about golf balls? Mine go in the trees. Never mind. Okay, parabola. Okay, everything that goes up has to come down. They follow parabola. Okay, so what is the maximum height? What are we looking for? The vertex. Okay, and actually the height is going to be the K. But how do we get there? Do we have to get this in standard form? I know you want to do that because you like doing that so much, right? Please don't. Okay? What can we do? Negative b over 2a. So let's first identify what a, b, and c is. What's your a? A is equal to negative 0.0032. Sorry about that. I carried away with my zeros there. Okay. Let's get it. And by the way, being a physicist too, you know where the 32 comes from? This isn't directly. Where those digits come from, remember we're in feet here. The acceleration due to gravity in the U.S. customary system, which is feet, that kind of thing, was 32 feet per second squared. So that's where the 32. Now, what they didn't tell you here, and I'll just let you know, the ball was initially hit. Nathan doesn't hit them this off, but 100 feet per second, that's its initial velocity. Okay? Because they divided by 100 squared, and that's why you got the 4 digits here. But don't worry about that, and that's why you don't have 100 here. Don't worry about it, but that's where it is. Okay? And, okay, we'll go further. There's your A. What's your B? 1. Do we even care what C is? No, we're not going to use it. We're only interested in minus B over 2A, right? You could write down C is equal to 3, but we're not going to use it. Okay? Unless you did the other formula, which is sort of bizarre. So, what do you get your X to be? And, I'm sorry, your H to be? Minus B, which is 1, over, okay, it's 2 times that, right? Okay, 2 minus B over 2A, but the A is negative 0.0032. Okay, and what is that? Well, I'll leave the minus there for now. 1 over a negative 0.006064, right? But these two minuses go away. That leaves us a plus. good news, right? If that was a minus, that's a foul ball way behind the catcher. Okay, not going to go any further there. But if both of those are positive, we're in fair territory, it looks like. Okay? Now we got to figure out what that is. Looks like a good place for a calculator, doesn't it? Someone do it for me. 1 divided by 0.0064. I know my writing stinks, but (156.25) feet. Okay, guess what? It's 156.25 feet from home plate. That's where the ball is going to reach its maximum height. I think that ball is on its way, okay? Believe in most parts, what's center field in our stadium? Do you know what it is? 400. It won't quite make it in center field. How about right or left? 330. Not quite going to make the fence with it, but it's going to be a pretty long fly ball, I guess. Okay? So, there's your H. What do we need to do now? We want to know the height, which is your F. Plug it in. F of 156.25 is equal to negative 0.0032 times 156.25 squared plus 156.25 plus 3. Don't forget your plus 3 there. Okay? And it's just a calculator problem that we can handle, can't we? Clean up that 5. That looks pretty bad. So what's the maximum height? (81.125 feet). Okay, so what if you're in the super dome? I think you won't hit the ceiling with it, will you? Nowhere close. Okay. All right. Yeah. So the maximum height, 81.125. Now, if you had wanted to do it the other way, you could have done the C, which is 3 minus, and then you could have done all those things. You probably would have gotten the same result. Hopefully you would have. Okay. Make sense? All right. What's that? See, the X was your distance from home plate. That's what we found there. That's where we reached the maximum height. Then to find out what the maximum height was, we had to plug it in here. Because up to that was the height. Good deal.
Those 2 points would be vertex, right?
Yeah, your HK. 156.25, 81.125. That's your vertex, way up there. Now, I was asking Nathan how far it was to the fence. You see, just about twice this distance is where it's going to come down again. And that would be right around 308, no, 312. It's not quite on the fence, is it? 312 and a half. All right. So, gonna have them on the warning track anyway. Okay. And the second baseman's gonna run back there and catch it. Okay. That's how we did it. Let's see how they did. Any questions before I erase it? Okay. So, for this quadratic function, we have f of x equal ax squared plus bx plus c. Yeah, we got it in that form. So therefore, this is in that form. So your a is negative 0.0032. The b is 1. And who cares what c is in what we're doing here? We don't use c. All we use is minus b over 2a. Okay? So that's the next thing we do. Your x value for your maximum height is going to be at minus b over 2a, which I like to call the vertex because that's what it is, h, except h may be confusing here because you might think that's height, and it's really not. It's the vertex, so x might be better here. Okay, and that's negative 1 over 2 times negative 0.0032. When you do that, 156.25 feet from home plate. That's where it's going to reach its maximum height. So you plug that into this function, just like we did, and do the calculations. Use your calculators. Folks, I hope you remember to bring calculators to your test because they will be helpful. By the way, know your calculator too. Don't come to the test and say, how do I do this? Get to know it ahead of time, so you don't have to waste time and get frustrated and ask questions. I'll help, but it sure helps to know it ahead of time. And when you do that, that gave you 81.125 feet. That's exactly what we got. Now, in reality, if your input values were basically no more than 2 digits anywhere, then how can you get 5 digits in your answers? You really can't. 156, near 160 feet from home plate, by 81 feet in the air. Really, you can't get more precision out of the problem than you put into it. But we're not going to argue about that now. That's more physics than math. Okay. And they say that's the last example in the text. And it is. However, they do have a checkpoint. And it's another baseball. And let's see. I think they've not quite hit it as hard. This is going to be called for sure, I think. Okay, let's look at vocabulary. Top of page 120. Any questions on 2.1? Summary was there. Let's look at the questions. Linear, constant, squaring functions are our example of blank functions. First word in the title of the chapter. Linear and constant are quadratic. Look at the first word in the title of the chapter. Polynomial functions, of course, okay? A polynomial function of x with degree n has the form of f of x is equal to a sub n, that's just a coefficient, x raised to the n, that means something, plus x minus 1, a to the n minus 1, that's just another counter, x to the n minus 1, that's the exponent, plus dot, 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 plus a1x plus a0, as long as a sub n is not equal to 0, where n is a blank blank. What is your n in that polynomial form? It's what? Okay, polynomial function, the f of x is your polynomial function. That little counter, which is the n, what is it? What does it have to be? In other words, what can your exponents not be in a polynomial function? Okay, non-negative integer. I think that's exactly what they want. I was going to say positive integer, but actually non-negative is better because it could be 0. Okay, you're right. And the a sub n, the a sub n minus 1, and all those other a's are blank numbers. Real numbers, they could be anything. Fraction, decimal, positive, negative, rational, irrational, it doesn't matter. Any real number. Okay, good. Number 3. A blank function is a second degree polynomial function. What's that? A blank function is a second degree polynomial function. Say again? Okay, squaring is the parent function of it. In general, if it's second degree, it's a, what's the first word in the title of this section? Quadratic function, okay, is a second degree polynomial function, and its graph is called a parabola. Excellent. Number 4, the graph of a quadratic function is symmetric about its axis, or axis of symmetry. Very good. Number 5, when the graph of a quadratic function opens upward, its leading coefficient is blank. Positive, and the vertex of the graph is a minimum value. Exactly. It's opening up. Okay, number 6, when the graph of a quadratic function opens downward, its leading coefficient is negative, and the vertex of the graph is a maximum. Very good. If I were you, I would do all of 7 through 12. Now, only the odd answers are in the back, but I would do them all and check the odd ones. If you get the odd ones right, you probably got the even ones right too. Then do either 13 or 15, or both if you choose. Do any of the odds 17 to 33, any of the odds 35 to 41. Do either 43 or 45, or both if you choose. And then, like we did today, this is where we started today, any of the odds 47 to 55. Then do 57. Good to look at that. Any of the odds 59 to 63. Any of the odds 65 to 69. I think we did one like that today. Either 71 or 73, or both if you choose. Do 75. Okay, a diver, what kind of path do they follow? A parabola, of course. Everything that goes up comes back down in the parabolic motion, okay? So do 75, any of the odds 75 through, wow, they got a lot of them, don't they? Through 85, okay? And I would pick the ones closest to your major and the ones you might just be interested in. But do some of those odds. Now look at 87 is a true-false. You won't see many of those on tests, but. And then a little bit more abstract, perhaps, is 89 or 91. And 93 is a pretty good problem. That's just what we did. 95 is a proof. If you're interested in that, go for it. That's up to you. And that's it for 2.1. Any questions? All right. Then let's move on to 2.2. All right, 2.1, we mentioned constant functions, we mentioned linear functions, but we really delved into quadratic functions, okay? Guess what we're going to do in 2.3? Higher level, okay? So 2.3, let me get the setup, correct slide. Continuing polynomial and rational functions. We're doing polynomials for the first 5 sections. We'll do rational functions in 6. So 2.2 is again polynomial functions, but now we're going to do higher degrees. 3, 4, 5, and so on. So, we'll go back and think about our transformations to sketch graphs of polynomial functions. And then we're going to come up with some keys, some tests, and things to look for. And they call it the leading coefficient test. I like to call it the leading term test, because it's more than just the coefficient. We use the whole term. The coefficient's included in the term, but more is there too, to determine the end behavior of the graphs of the polynomial function. In other words, what's happening for very large x's and very small x's. Way out. Very, very negative, very, very positive. That's what we mean by end behavior. We'll find and use the real zeros of the polynomial function as sketching aids. So actually, this finding the end behavior is going to be a sketching aid, and then finding the zeros will be a sketching aid. Because guess what? They love graphing, don't they? And then we'll use the intermediate value theorem to help locate real zeros of polynomial functions that maybe you can't find so easily. Okay? So we'll do all of that. Let's start with the graphs of polynomial functions. Okay? This section will study the basic features of the graphs of polynomial features. The first feature is that the graph of all polynomial functions are continuous. Every graph of every polynomial function is continuous. What do we mean by that? Yes, you don't have it. Say again? Okay. from all in there, you never have any gaps, holes, anything else. So this looks like it's starting, and the more negative you go, it's just going to go more negative here. That's an end behavior issue. Okay, it's coming up, smooth. Well, so I shouldn't say that yet. Goes here and here and here, and it looks like it just keeps on trucking. Okay, never any breaks, never gaps, never missing values. That's what it means by continuous. Essentially, this means that the graph of the polynomial function has no breaks, no holes, no gaps. Okay? Now, there's one other feature we're going to focus on. I hope it's going to come soon because I keep wanting to say it. And they're not going to say it now. You think this is a polynomial function? No. This looks like what we call a piecewise function. Now, this piece over here may be polynomial, and this piece over here looks like it could be polynomial. But guess what? Together it's not. Why? There's a break there. And polynomial functions have to be continuous. This is not a continuous function. Okay? In nature, do you ever hit that? You might somewhere, but I can't think of anywhere. Everything in nature just is continuous. You don't have just sudden shifts and breaks. Okay? Most things are continuous. Okay? All right, so that's not a polynomial function because it's not continuous. Now, how about this one? That easily could be a polynomial function because it's continuous. But the second feature of a graph of a polynomial function that it has, when it does change direction, there's smooth, gradual changes. You don't have any points, cusps, peaks, or sharp valleys. They always are smooth, 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 smooth. No jagged edges anywhere. Only smooth, rounded terms. I like to say like jazz, smooth. Polynomial functions have two things. They're smooth and they're continuous. Polynomial functions are always those two, smooth and continuous. Okay? Is this a polynomial function? No. It comes down like this. Even though it's continuous and goes up like this, it's not smooth. It makes a sudden change of direction. The smooth, gradual change of direction. That has a corner of an edge, whatever you've done. No sharp turns. Okay? That's the absolute value function. One of our parent functions, but not a polynomial function. Okay? Later, hopefully some of you will get the calculus. Yes, okay. And when you do, we'll have slightly different ways to define this that are a lot nicer than general words. Okay. The graphs of polynomial functions of degree greater than 2 are more difficult to analyze than the graphs of polynomials of degree 0, that would be constant functions, degree 1, that would be linear functions, or degree 2, that would be quadratic functions. Those are easy. Okay? When you have higher degree, you have to do a little more playing around, looking at some different features. Okay? That's what we're going to be doing. However, those features presented in this section, coupled with your knowledge of point plotting, intercept, symmetry, that kind of stuff, you should be able to make reasonably accurate sketches by hand. Okay? Get your graph paper, do it. Okay? Polynomial functions that have the simplest graphs are the monomials of the form f of x is equal to x to the n. Now, if that n was 0, then that's a constant function. If n is 1, that's the identity function. And if n is 2, that's your squaring function. Okay? But if n is an integer greater than 0, I would say greater than 2, then this is the form we talked about for higher levels. But for any polynomial functions, anything greater than 2. Okay. Now, let's go to the x squared. We know that, right? The parabola. Y is equal to x squared. That's that gray curve right there. What if you have x to the 4th? It's going to act a lot like it, except it's going to be steeper outside plus or minus 1. By the way, for these two functions, 0, 0 fits on both of them. and 1, 1 fits on both of them. Negative 1, 1 fits on both of them. Okay? So the differences come outside of minus 1 and plus 1. And the higher the order, the faster it goes up. The smaller the order, the slower it goes up. It still goes up. Okay? Between minus 1 and 1, especially near 0, it gets flatter because it comes down steeper and then has to flatten out for longer. So that's why. So if you did x to the 6, it would be a little bit steeper here, a little bit flatter longer here, and then steeper here. X to the 16th would be, the higher it gets, the steeper it is outside plus or minus 1 or near plus or minus 1, and the flatter it is near 0. Okay, flatter longer. Now, I wish they had done y is equal to x. That would be your identity function. Straight line, linear function. But y is equal to x cubed comes up, this is the gray line here, and it goes like this, and y is equal to x to the 5th, comes up, and again, notice here, 0, 0's on both of those, 1, 1's on both of those, just like they are on here. But over here, minus 1 becomes minus 1 on both of those, because it's an odd power. Okay? So, again, x cubed is like this, the gray line, and x to the 5th is the darker line. Steeper outside plus or minus 1, flatter near 0. Flatter for longer near 0. Okay? Not perfectly flat, but it's closer to being flat. Now, notice this. When the exponent is even, it's always positive. No matter what number you put a negative number, raise it to even power, it's positive. An odd positive number, raise it to even power, it's positive, okay? It's positive going in both directions. That's what we mean by in behavior, okay? But if this maximum exponent is negative, that means the x cubed is going to be negative. For negative x's, a negative number raised to the 3rd power is going to be negative. A positive number raised to the 3rd, 5th, 7th power is always positive. In fact, any positive number raised to any power is positive. But a negative number raised to an odd power is going to be negative. So again, your in behavior is like this. Negative for negative, positive for positive. Even powers, positive for negatives and positive for positives. Yeah. As you get larger and larger, it gets more and more positive. Okay, that's going to be key for later. Now, right now, we're just looking at the power functions, just no coefficients and no other terms. This is how they look. And it's important, okay? What you notice is what the n is. Is it odd? Is it even? Okay? That's going to determine the n behavior. Moreover, the greater the value of n, the flatter it is near the origin, and the steeper it is outside plus or minus 1. They didn't say the second part, but it's still true. Okay, so let's do something. Sketch the graph of each function. Okay? Whoa, this is still red. Let's get out of red and go to dark. Okay. All right. F of x is equal to minus x to the 5th. Now we can do this brute force, just attack it, or we could go back and do parent functions if you wanted to. How would you like to do it? It's up to you. Go for it. So give me an x. 1, okay? Let's put an x of 1 here, minus 1 here, 1 here. This is going to really come back and bite me later, but okay. So when you put a 1 in, what do you get? Negative 1, okay? Give me another x. Negative 1, okay? I sort of gave that away, didn't I? You put a negative 1 in, raise it to the 5th power, that becomes, well, raise it to the 5th power, it's still negative 1, but then you negate it, and it becomes positive 1. So you're absolutely right. Give me another point. 0, 0 is certainly there, okay? Now, if we went out to 2, what would this be? Two to the 5th, this one. Yeah, 2 to the 5th, which would be 32. Negate that minus 32. That's way, way downhill here, isn't it? Okay, so it comes up here really steeply and then passes through here and stays flat, fairly flat pretty long, then cuts up, and if you put in a minus 2 to the 5th would be negative 32, but negate that, it would be positive 32, so this goes up really, really fast too. So it's something like that. My drawing leaves a lot to be desired. I get to talking and don't pay attention. Okay, so that's what it looks like. What the minus sign here has done is flipped it across the x-axis. Okay, because that would have been going the opposite direction, but the minus sign flips it. Okay. H, what color you want H to be? Pick a color. Second? Blue? Baby blue, right? Carolina blue, yeah, okay. It's March Madness, isn't it? Okay. So, x plus 1 to the 4th. I definitely think translation is in order here. What would this do? X plus 1 to the 4th power. To the left, how much? 1. So that's going to be, rather than 0, 0, it's going to be negative 1, 0. Right? Okay. And then, right or left from there? Real easy to plug in a 0. X equals 0, that'd be 1 to the 4th, which is 1. And then, what happens if I go the same thing to the left? It will also be 1 because this is to an even power. See, this is an odd power, so it goes in opposite directions. Even power go in the same direction, and those are both going up. And if I went one more tick to the right, what would be, if you put a 1 in here, 1 plus 1 is 2, 2 to the 4th is 16. So it's going to be way up there really quickly. So it's going to come down like this, hang around near 0 pretty long, and then shoot up like that. Not a parabola, a flatter down here parabola and steeper over there parabola. But it looks a lot like a parabola. Right? Make sense? With a horizontal shift to the left one. Your vertex is not at 0, 0, it's at negative 1, 0. All right. That's how we did it. Let's see how they do it. Any questions for our eraser? Okay. Because the degree of f of x equals minus x to the 5th is odd, the graph is similar to y is equal to x cubed. Now, they didn't draw it, but you know what that looks like. It's like this. Okay? But the minus sign flips it, and the raise it to the 5th power rather than cubing it, keeps it flatter here and steeper here. Okay? So, yeah, that's what it looks like. Flipped and flatter and steeper. Okay. Notice that the negative coefficient has the effect of reflecting the graph in the x-axis. Make sense? Pretty much what we did. We picked out a few points, which is fine. Okay. Now, this one, though, is a left shift by 1 unit. Okay. Over here from 0, 0, it would have been to negative 1, 0. Real easy to plug in a 0 for x and find out that's 1. And because of symmetry, we're going to be at negative 2, 1 also. But because it's to the 4th power, it's flatter down here than your normal parabola is, and steeper outside, plus or minus 1. Or 1 away from the vertex, plus or minus 1 away from the vertex. And that would be steeper outside that. Okay. Make sense? Pretty good so far, right? Now, that was example 1. There are some checkpoints here. They have 4 in the checkpoint. I would definitely go home and play with those. Now let's look at what they call the leading coefficient test. I like to call it the leading term test. Okay? In example 1, note that both graphs eventually rise or fall without bound as x moves from the left to the right, or to the right. Okay? What they're saying there is with a polynomial function, in time it's going to get incredibly large. When x's get large, the polynomial gets very large, either large positive or large negative. When x gets very large negative, it's either very large positive or very large negative. They go increasing without bounds. And after a while, they don't turn and come back, they just keep going. Okay. Whether the graph of a polynomial function eventually rises or falls can be determined by the function's degree. Now, what do we mean by the function's degree? Okay, it deals with the leading term. And by the way, the leading term, does that mean the first term always? No. What makes it a leading term? The highest power, the maximum exponent. That's what you look for. So the degree of the function is the maximum exponent in that function. That's what the degree is. If that maximum exponent, if the degree of the function is even or odd, if it's even, you know those things are going in the same direction, whether they're up or down. Okay? If they're odd, they're going in opposite directions. We just don't know which yet. Okay? That's where, and you see, that's not the coefficient. That's the maximum exponent. So that's why I call it the leading term test. Because the leading term contains the coefficient, but it also contains that maximum exponent. So that's why I like to call it the leading term test. Because this is dealing with degree, which has not got anything to do with the coefficient. And by the leading coefficient. Now, what does that tell you? And what tells you about it? No, not even. Positive or negative. If it's positive and an even exponent, it's on the up and up. If it's negative leading coefficient, but even coefficients, down, down. If it's positive leading coefficient with an odd degree, then it's going like you would expect it to. Down to the left, up to the right, up to the right. Sit down, 5, 5. No, okay. And if it's a negative, it reverses. Okay? So basically, pay attention to that leading term. Those other terms, they give you the wiggles and the squiggles in the middle. The leading term tells you what's happening on the extremes. Okay? So I like to call it the leading term test. And unfortunately, that's all I get to call it today, because we're going to pick up here next time. Ooh, we got just a little further than we did last time. Okay. Okay. So, did we get enough covered to do any homework? Yeah, we did. I think you can do all of 9 through 14. I'm not sure you can. Try to do some of 9 through 14, okay? Just to see if you can figure those out. If you can't, don't get frustrated. We'll do more of those later. Why they put those first, I'm not sure. Then do some of the odds 15 through, well, either 15 or 17. And we did do those today. And we haven't done applying the leading coefficient test, so we'll hold off on that yet. Okay, good deal. For those who came in late, okay, I announced this earlier, and because you came in, you may not go back and listen to the YouTube video, but UAB is having a showing of Hidden Figures. Did y'all know the movie? Did you get to see it? Yeah. You did. Amazing story, isn't it? Incredible story, and a pretty good movie. Okay. They're going to be showing this tomorrow evening at 5 o'clock in the Hill University Student Center. So if you can go. Lawson has been invited to come. So there may be transportation from the Birmingham campus. I haven't heard of any from here. I'm not even sure about Birmingham, but you can ask around and find out, okay, if there is. But parking is the only issue on the UAB campus. Hill University Center is on University Avenue, which was 8th Avenue before, but they changed it through the University Avenue. North of that, the numbers go down, 7th, 6th, and 5th. I don't know if 7th has any available parking or not. It's pretty crowded there. But 5th and 6th do. They have some parking along there, and if you park along there, I think you can do it without a meter, or maybe after 5 you don't have to pay the meter. I don't know. I don't know what the rules are, but that's where I'm going to try to park if I get to go, is there. So don't get tickets. UAB campus, they're probably just about the same way they are here, okay? But it's well worth the trip. It's free, okay? Or at least Ryan said he'd pay for us if it wasn't. Okay? So, didn't you? Okay. So, well worth the effort. Great movie. Great story. If anyone needs direction on how to get to Hill University Center, they call it Student Center now, I'll be glad to answer that. All right, good deal.